So today is week 11 of 13. We've only got one more lesson after today. So just kind of a quick look ahead as to what's going on over the next few weeks. So today we're going to look at unit testing in ASP.NET. Normally I allocate 2 weeks of class time for this lesson, but because we have a shortened semester, what we actually lost was our second class on unit testing. So we're not going to take quite as deep a dive into it as we would normally, but that's okay. We'll still get to do some unit testing. We're going to look at assignment 2, part 2 as well in a moment. I've also scaled back significantly the requirements of it. It is due next week, but it's much smaller than I had originally intended. So we're going to do that this week, and your assignment will be due on Tuesday. Next week, we're going to build a web API. That's a fairly short lesson. Maybe in my Tuesday class, that was maybe a 90-minute lesson. And then I'll give you assignment 2C, which is very short. Literally should take less than half an hour to do 2C. And that is due on the Tuesday before the final exam. So our final exam is in 2 weeks. It's from 11 a.m. to 2 p.m. I will talk a little bit about the format of the exam. The exam is going to be all practical. There are no quiz questions. There's no question and answer whatsoever. I'm going to give you an application to start with, so you're not going to have to build an application from scratch. I think everybody knows how to set up a project already. And in fact, what we're actually going to do for the final exam is I'm going to give you a copy of our .NET Duds project. I know you have your own, but I'm going to make sure everyone's starting with the same copy of the application. And then for your exam, you're going to be adding a number of new features to the store that we didn't have time to do this semester. So some of those will be really simple requirements worth a few marks. Some of those will be a little bit more advanced, which will be worth more marks. Things are also going to be randomized. So I'm going to make up a whole list of requirements, and everybody's going to get a subset of those requirements. So your exam is not going to be exactly the same as someone else's. But we're all going to be working within the store with which you are already familiar. Okay. It's also possible that in the starter project I give you, there may be a few bugs that you will need to fix in order to be able to get the project to run. So you'll sign into the WebEx room. I'll open it up before 11. I'll go over the instructions right at the start of the exam, and then you'll want to stay in the WebEx room so that if you have any questions or have problems during the exam, you can use the chat to ask a question. Okay? And the exam counts, I believe, for 25% of your final mark, although I would have to double check the syllabus to confirm that. You will not need to use Azure at all for the exam. I know a lot of you are running out of credit, so you don't need to worry about that. Azure will not be used at all. In terms of content, pretty much, we didn't have a midterm exam. Normally when I have a midterm and a final exam, the final exam focuses more on the learning outcomes of the second half of the course. But since we've had no exams at all, really anything we've done in any content in the course might be something I could ask you to do. Does anybody have questions at all about the exam?
Yeah, so when you mean like bigger features, do you mean like adding like something like we've never seen before? Like, do you mean like adding like new pages? Do you mean like making like tables? Like, can we just get like an idea? Because adding new features we've never seen before is very broad and very intimidating. That's just a sentence.
I'm not going to ask you to do anything that I haven't taught you.
Okay.
But we've learned a lot, so I may ask you to adapt some of the things we've already done into the store. So, a simple task would be something like create a new static page, right? Like create a new link in the footer and a new static page that loads from that. So that would be something like that would be a simple task.
Okay.
For example. A more complicated task might be something like one of the things we didn't do, for example, is if I shop. So one of the things we never did was there's no ability to update the quantity of an item, right? We can delete and we can add to cart. So a more advanced feature would be to be able to make it so the user could update the quantity of an item in their carts.
Okay.
I'm
Okay.
not
So
saying that specific feature will be included. It might be, it might not be, but that would be the kind of thing.
okay. So it's nothing. It's nothing too crazy. Okay.
No, it will be taking the skills we've already learned and then applying them to improve the project, right? Like if you think about, okay, if we had another month worth of class, what else might we do with this to polish it, make it more fully featured, etc. So those would be the kinds of things I'm going to ask you to do, but there'll be sort of some different levels of task from the simple to the more complicated. The simple ones obviously are not going to be worth as many marks as the more complex tasks.
Okay.
Is that fair?
Wait, can you hear me? Rich?
Yep.
I just have how do you want us to prepare for this exam other than like going through your videos and like try to rewrite some of the code and stuff like that? Is there any sort of tips you can give us?
That's a great
preparing for
question.
this?
Great question. One thing I can recommend that you try is in your assignment. Well, first of all, doing assignment 2, part 2 and part 3 are going to help you because there will be unit testing and web API on the exam. So make sure you do the next 2 assignments. That would be one thing. Another thing you could do just as a way of practicing is you could go back to your original assignment submission and take a look like, what else could I add to this? Right? Like it's like if you have a functional site, how could I make it better? What features on here would make it more polished, would make it easier for people to use? And you could try adding some of those features. You don't have to like publish those to GitHub or Azure, but you could work locally on a copy.
Yeah.
And go through it and say, okay, I did the basics to get my marks, but if I was going to launch this as a real site, what else could I put in here? Or what else could I do to it to make it more professional?
Yeah, that sounds good. Okay, yes. Yeah, that's actually, yeah, that helps. That actually helps a lot. Yeah, thank you.
Okay. Good, great question.
Thank you.
And certainly if there are any things in your assignment, like from assignment 1, that really weren't working properly, you could go back and fix those up. Again, that's a way of practicing. Are there any other questions about the assignment? Sorry, about the exam. Okay, if not, let's have a look. I'm going to go over assignment 2, part 2. That's due next week on Tuesday. For part 2, all I need is your GitHub link. You don't have to turn your Azure site on for this. I'm going to have to run everyone's projects locally anyway. So there's no need to restart your Azure service if it's stopped right now. Okay. You do have to write your own work. Please don't just copy today's work from GitHub, download it, change the words, and give it back to me. Okay? It's there as a reference. I will know my own code when I see it. I know my coding style. So if your code is an exact replica of mine, I'm not going to give you a grade for it. Okay? I realize certain things are obviously going to be similar, but if it looks exactly the same, all the spacing, all the tabs, all the indenting, all the comments, I'm going to know it's my code. So use what we're doing together in class as a reference, but write the code yourself. So what we are going to do is implement unit testing in your assignment. And this is exactly what we're going to do today in class. So you're going to create a unit testing project within your existing assignment, and you'll create a test class for only one of your controllers. you're going to create an in-memory database with 3 mock records. We're going to do this in class today. And then you're going to write a suite or a set of unit tests for only one of these methods. And you can choose which method you do. In a normal 14-week semester, in this assignment, you have to write all of the unit tests, which comes out to somewhere in the neighborhood of 25 to 30 tests. Because we're on a compressed timeline, you only have to do 1/6 of that amount of work. Okay, so you do not need to write unit tests for all of these. For whichever method you choose one of these methods, and you'll write a separate test for each outcome that can occur in that method. So typically that means you'll need between 3 and 5 unit tests, which is not a lot. So please don't do all of them, just choose one. And a few tips. I'm going to come back to these tips later on. They're not going to make much sense right now. They'll make more sense. I'll refer back to these at the end of today's lesson. And then just make a couple, minimum 2 commits to GitHub. So make a commit when you first set up your unit testing project in your unit testing class. You can make another commit when you're finished. That's sufficient. Okay, there are no bonus marks for this part of the assignment. Does anybody have any questions about these requirements? Okay, I will leave the assignment document open so I can come back and refer to these hints later on that I've provided. So make sure you've got your .NET Duds application open and you can run it. So we're not really working in the front end of the application today. We want to deal with unit testing. So I'm not going to read this to you. But take a minute to look at what Scott Guthrie, who's a very prominent .NET developer, says about unit testing. So what is unit testing and why should we spend today's class learning about it? Yeah, Lindsay, absolutely. So it automates testing. It reduces the potential for manual fixes from a new improvement. Yep, so it makes our code easier to maintain over time. Because we write an application today, yep, Dan, that's another great one. Unit testing helps us identify bugs before we release our application into production. It's another good reason. Yeah, and Kevin, that's a really important one. It makes it safer to try new stuff. It's easier to see what works and what breaks. Jeffrey's saying, yeah, it helps us reduce bugs. Yeah, and Jillian said, it's much like bug testing. It catches stuff we may not realize. So here's a common scenario. We build an application today, and then we put that application in production. People start using it. And then sometime in the future, we've moved on. We're working on other projects in 6 months, even a year, 2 years down the road. Suddenly, our client comes back to us with a list of updates that they want. So now the code's no longer fresh in our mind. We don't necessarily remember all the logic. Now we've got to go back into this old code base and make changes. So what very commonly happens in that scenario is we make a change for something new that's needed, and that winds up breaking code that worked previously. And then we're in this scramble because now our new version has broken something that used to work. If we roll back, we're now lost all of our new code. So unit testing is designed as a way to catch those things for us. We make updates, and before we roll out those updates, we run all our unit tests from the existing batch, not only unit testing the new features, but all our original unit tests. And those unit tests are going to tell us if we've broken anything that used to be working. So unit testing generally is done now. Have you guys, I think you guys have done, yes, commenting absolutely helps. Yes, Jeffrey, that's another good point. It's testing what the application does if it gets bad data. So we can simulate those scenarios. Yeah, commenting helps, but even then, I have a couple of applications that are still in production. Like one of them I created in 2006. Can you imagine trying to go back to an application that old and change it? So we're working this class, we decide to change the cart. Yeah, absolutely it would help. So we update the cart, and then we can run our unit test and see if everything still works, or did things break from those updates. So unit testing is designed to help us make those updates. And the key thing about unit testing, it's at a very small scale. So a unit test is at a very granular level. So typically, a unit test is testing the behavior usually of a single function or method. So we want to look at one method at a time and determine, what are all the possible outcomes of this method, and we want to write a unit test for each one of those scenarios. That's why in your assignment, I've said, for example, if you're doing the create get method, you'll have 3 to 5 tests. Jillian, I'll come to your question in a second because it's an excellent one. So here's let's say our orders controller. That's not a good one. I'll go to my products controller. So let's take a look at our create method, our get create. If we were going to unit test this method, how many different things can happen here? How many unit tests do you think we need to completely cover the different scenarios? Okay, so Kevin, what 2 things do you see here that we might want to write unit tests for? Yeah, 1 for each. So what's happening on line 57? What's this code doing? Yep. It's ordering by, and what happens with this data? What are we doing with it? No, we're not creating a new product. Remember, this is the get method. So this is called, in our application, when an administrator, let me just log in, we eventually will be creating a new product, but we're not creating the new product yet. So I go to products. When I click create new, this runs the get method. So what is line 57 doing in relation to the behavior of our application? Why do we have line 57? Kevin, you got it. It's populating the list of categories in the view. So this is one thing we would want to test. Yeah, you're right, Mike and Kevin. So there's one test, because that's one thing that happens here. What about line 58? What happens here? Yeah, we're loading the products create view. So to properly test this method, I would suggest we need 2 unit tests. One that checks that we have a list of categories, and another one that checks that we have the correct view returned. Now, some developers will write 1 unit test and check this first and check this second. I don't think that's a great idea. Other developers like me, we kind of really strongly stay away from that practice. My feeling is we've got 2 different scenarios, 2 different things happening in the method. So to test it, we should write 2 separate unit tests. Why? Why might it be better practice to write 2 tests rather than to check both of these things in a single test? You can do it. Some developers would write 1. Yes, Kevin, but can you be a bit more specific? What's the downside? Right. Okay, so yes, Taylor, part of it is for simplicity, but the other, as Jillian, so Taylor, you and Dan said, yeah, it's easier to write 2 tests, but and easier to read. But Jillian and Jeffrey also made the point, well, what if one thing fails? If one fails and one passes, if it's only in one test, we don't know which failed. Did the categories query fail, or did loading the correct view fail? There's 2 separate results. So testing them both together in one unit test, I would suggest, is a poor idea, even though some developers will do it. So I think it would be better to have 2 separate tests, each one that is testing one specific thing only. That way, if one of them fails, we know which part of the code failed. So Jillian, I'm coming back to your question now. Why would we not unit test? Really, lack of knowledge, laziness, lack of time. Those are the only reasons. Well, the unit testing project, remember, it goes in a separate project. It's within the solution, but it's not part of the project, so it doesn't really add code bloat. Now, some organizations even use a methodology called TDD. Anybody have an idea what TDD is? Jeffrey, somehow I have a feeling you know what it means. Test-driven. And what's the other D? Yeah, test-driven development. So what is test-driven development? Or what might you hypothesize? We're not going to really use test-driven development. It's kind of a different methodology, but many of you will wind up working in places where that's how they build applications. Exactly. So rather than write the code and then test it, in test-driven development, you actually write all the unit tests first, and then you write the code in the application. Why would you do that? Right, so you can test each part and you make sure that it's not so much everything works, but we're thinking through clearly all of the scenarios our application can take. Rather than writing the code and hoping we've coded them correctly, test-driven development forces us to really plan out all the execution paths of an application and then decide in every scenario what should the application do. So then we have a really good structure predefined when we actually go to write our code. So a little bit beyond the scope of our course today, that's right, we can make the parameters for bug testing before we even write the app. So it forces us to think about the bugs and the bad data and all the stuff that could happen right from the beginning, rather than we tend to write applications so that, we think about how should things work, and we do things in the way they're supposed to work, and often we don't think about the outlier scenarios. No, we don't always, but the idea of TDD is we're trying to think about it in a much more organized and structured way ahead of time. So we're not going to do TDD, but it's just something that you should be aware of. Okay. So Visual Studio has a number of testing tools, and we're going to work with some of them. So before we do, I'm just going to set up, we are going to do some unit tests in our products controller, but just for now to set it up, I'm going to create another controller, just a really basic controller that doesn't use our database, just so we can do some simple unit tests first. Because when we're unit testing a controller that uses a database, things get a little more complex. So I don't want to start there. Let's start slow and we'll work up to this part. So in your project, let's create a new controller. Just right-click controllers, choose add controller. We're going to pick an empty controller. Excuse me. I'll just call it dummies controller. The name doesn't really matter. We're not using this for anything else in the web application. We just want to try out some basic unit tests. So we get a controller, and whenever we create a controller, it automatically gives us an index method that will return a view. So this is enough for us to try a few simple unit tests. So create your controller, and now I'm going to create an index, a dummies index view as well. So in my Solution Explorer, I'll go down to the Views area. Yep, we're getting there, Jeffrey. I'll right-click Views. I'll click Add a new folder called Dummies. And then in here, I'll just create an empty view called Index. So I'll right-click my Views and Dummies. We'll choose Add a View. We're just going to pick an empty view. It defaults to the name index, which is great. That's the name we want anyway. So I'll add it to the project. And I'll maybe just put on just so if we load this in the browser, there's some content that appears in the middle of the page. So again, create an empty controller, a subfolder called Dummies in Views, and just a static empty view. I can load it in the browser at my root domain /dummies. So it should just load our static page. So we just get a static page, and now we can try playing around with some unit tests with this. So in Visual Studio, you'll notice at the very top, it says Solution 1 of 1 project. So the only project in here is our web project. We're now going to add a separate project for unit testing. So I'm going to right click on my solution. I'm going to choose add a new project. And up here in the search box, I'm going to search for the word MS test with no spaces. Visual Studio supports 3 different unit testing frameworks. There's MS Test, which of course is Microsoft's own library. There's also a unit testing framework called NUnit and another one called XUnit. We're going to use MS Test. So when I search MS Test, I get 3 project templates showing up at the top. MS Test project .NET Core in C#, another template in Visual Basic, and one in F#. Obviously, I want the C#. I really haven't worked. They're all similar, Jeffrey. I don't have an informed opinion. I've mostly just worked with MS Test, so I can't comment intelligently. I think NUnit may actually be more popular. So we can see if I scroll down, I should see the XUnit as well. So here's XUnit. They're all similar. I'm going to use MS Test. Make sure you pick the C# option and click Next. I'll call it .NET Duds Tests. And then I'll click Create. You can call the project anything you like, but it's a good idea it has the name tests in it to make it clear that this is the unit testing project. So it creates a new project down here, gives us a class called Unit Test 1. It references the Microsoft Test Tools unit testing namespace. And this looks kind of like a controller class, a regular class, but notice here, it's got a test class decorator, and this has a test method. So any classes for unit testing will have to have this at the top over the class definition. And each unit test needs to have test method. This tells Visual Studio, hey, this is a test that can actually be executed and evaluated. This is not just a regular method in the application. Now it's called Unit Test 1. I'm going to refactor that. I'm going to rename it. So in Solution Explorer, I'm going to right click and rename this to Dummies Controller Test. And when I hit enter, Visual Studio will ask if I want to rename all the references. I'm going to say yes. So that's going to change my class name as well. One other really important gotcha when you're doing unit tests in Visual Studio. Your unit testing classes have to be public. Because there is a testing tool in Visual Studio, it will ignore any class that is not any unit test class that's not declared with in the public scope. So your class and your unit test methods should be public. So we're going to write our first test method, and typically calling the method names are important. The general structure of a unit test method name is we indicate what method are we calling and what result are we testing for, what scenario are we expecting. So we're going to test the index method of our dummies controller. We'll say index returns something. It's not going to be a great unit test. We're just checking that if we call the index method, something comes back. And there's 3 basic steps in any unit test. Doesn't matter whether we're in the Microsoft world, Java, JavaScript, anything, any other. It's just a pattern. So we've got arrange. So set up any variables objects needed for the method and scenario we want to test. Second, we act. Execute the method and store the result returned, if there is one. And our final step is the assertion. Evaluate if the result is as expected. So we go through this same process in every unit test. Set up anything we need, and occasionally we don't need anything. Run the actual method we're testing, and then determine if the result is what we expected. So here for our arrange, if we want to test the index method in this controller, we need to instantiate an instance of our controller. Our controller equals new. Now we're going to have to make a couple of quick changes here in order to instantiate an instance of our object. So the first thing we're missing is a reference. And the reference we need is actually down here. We need to reference the web project. So now we can create a new instance of our controller. We then want to call the index method. So we'll create a variable called result. And then we can execute the index method on our controller. So this runs the method we want to test. And lastly, we just want to check that this result we got back something. We didn't get back a null because our method returns a view. So we want to use the assert command in .NET, and you can see some of the methods, some of the things we can assert, we can test for. Are two things equal? Is something true or false? Is something null or not null? We can check the type of object being returned. So what we want is we want to assert that our result, when we call the index method, we get something back. We're not even really caring what we get back. We just want something back. So here's the method. I'll put this whole thing up on Pastebin for the moment, and we'll try it. We can run the unit test. Let's see what happens. There are a whole bunch of different locations within Visual Studio that we can use to execute the unit test. So I'll show you some of the different windows. So one way to run the test is just right-click the test method and choose. Actually, I'm going to show you one thing first. I'm going to go to my dummies controller. Notice now it shows there's one reference. So Visual Studio recognizes our unit test well, we'll come back to that question, Jeffrey. So if I right click, I can choose Run Test. So it builds the solution. And then it's going to open. Mine is already open. There's the Test Explorer window, which you can also get through the Test menu. You can click Test and Test Explorer. And it shows me one test. And when we run it, our unit test passes. If I go back to Visual Studio, back to my unit test, I now have one green check mark telling me the last time I ran my tests, this passed. If I go to my dummies controller, it also now updates and tells us this method is now covered by one unit test that is passing. Now, this isn't a great test because it just tells us that something came back, but it doesn't tell us what came back. So it works, but it's not great. It's not very useful. Let's try a test that's a little bit better. I'll leave this test here. What would be a better scenario for us to check looking at this method? Right now, all we're checking is that the test returns something, but if this test returned, let's say, a false, this method returned false, our test would still pass. Where if it returned a 404 error, our original unit test, it's still going to pass. So if we want to write a better unit test for this method, what could we be checking that's more specific about the outcome of the method? What should the outcome of this method be? Right, it returns the dummies index view. So let's write a more specific test to check that. We'll call it index loads. Maybe we'll call it loads index view. Right? That's a better test. It more accurately describes what should happen inside this method. So our arrange let's try it. Our arrange and act are basically the same. Instantiate an instance of the controller, call the index method. But the assert is going to be different. So instead of asserting is not null, we're going to use the r=equal method. And r=equal takes two parameters. What did we expect? And what did we get? Yes, and we'll look at that a bit later. So we are expecting a view called index, and we get back our result dot. Now we got a little bit of an issue here. When we check our result is of type iActionResult. This is a parent class. Yet what's actually being returned is a view result. So view result inherits from iActionResult. So what we'll need to do is, before we can inspect the name of the view that's returned, we need to cast this as a view result first. Cast. And when I do this, I get an error. Visual Studio doesn't understand in the test project what a view result class is. So we just add a missing reference here to Microsoft.ASP.NET Core.MVC. So I just add this reference, and now suddenly my error goes away. View result turns a light blue, my reference gets added on line 2. So now if I try my result again, I can now inspect the view name. And I'm asserting my test is saying the view name should be equal to the string index with a capital I. So I'm going to save that. And then I can either run all my tests again through Test Explorer. I could just click Run All Tests. I can just run everything here. So this test didn't run. I'm just going to run it. In our index loads index view fails. We expected index, but we got nothing. Well, that's kind of odd, isn't it? Because in the browser, this code works fine. If I call dummies/index, it's loading the correct page, yet the unit testing is telling me, hey, so we get an X here. It says when we ran the test, we expected index, we got null. So why did this work? Why did this happen? So this is an example of where the unit test is going to help us write better code. Let's check out what happens here. I'm going to put a breakpoint here. I'm going to run my test again in debug mode. So I can just right click my test and I'll click debug. It's going to run the unit test again. Okay. So I'll press F11 to jump to the next line. It returns a view. Yet my result, you'll notice the result, the view name is empty. It's null. There's no status code, no view name, nothing in the view data. So why would the view name be null? If there is some .NET magic, here's a hint. There's nothing wrong with our unit test. The unit test is actually fine. But what the unit test is pointing to is it's telling us there's something in the index method we should improve in terms of the code. Yes, it does actually work in the browser. Good guess, Lindsay. No, we're not using the view bag. Let's go back here for a minute. So I'll go back to my method. So in this return view statement, it's saying the name of the view is null. What do you suppose we could do here to be more explicit about exactly which view is supposed to load? This return view statement, yeah, it's overloaded, right? We've been using this one, no parameters. We've used this one sometimes before where we return a view and pass in a data model, but there's a third overload, which is string view name. So we should be specifying explicitly in any return view statements exactly the name of the view that loads, even if the name's the same as the method. The scaffolding does this, right? When we look at all the return view statements from scaffolding, it never defines the name of the view in any of these statements. The unit tests are telling us that's not great practice. So what's better practice is wherever we have a return view statement, the first parameter should explicitly be the name of the view. So I'm going to save that. And I can even run my test from here. So it says 1 of 2 passing. I'll just run them right from my method. And now, my second time around, now that we've explicitly added the index to the name, my tests pass. So now I've got 2 passing tests. So this is one of the hints I put in the assignment. I said I'd refer back to it. So whichever method you use in your assignment, if there is a return view statement, and there is in any one of these methods, you should do what we just did. Explicitly add the name of the view as a string. And that should be the first parameter in the return view statement. So in the orders controller, for example, here, we have return view, it's also returning an order. This is the details method. So we should be rewriting it this way, for example. The name of the view is the first parameter, and then the data model is the second parameter. So any method you use for your assignment, you'll need to do this. Add the explicit name of the view into that return statement. Otherwise, when you check that in your unit test, it's going to say the view name is null. Now, Lindsay, you mentioned the view bag. We'll come back to that because that's another thing we said when we were looking at our product controller, when we were here, we used the view data, which is basically like the view bag. So we'll see how we might test for this later as well. Okay. And Jeffrey, I will also come back to your question as well about how many unit tests do we write? Lots of them. We'll look at it a bit more. Okay, let's take a pause here. Get up, go stretch your legs. And we will come back at 12:05 and we'll move on to something a little more advanced with this. Okay, I will upload what I've done so far as well.